Imagine a world hidden beneath a thick blanket of ice, a realm teeming with bizarre life forms unseen by human eyes for millennia. Now, picture the moment when a colossal iceberg, a floating behemoth ripped free from the Antarctic ice shelf, unveils a secret treasure trove of ancient life. This is precisely what happened in January 2025. The iceberg A84, a slab of ice comparable in size to the entire city of Chicago, fractured away from the George V ice shelf in Antarctica. This massive ice shelf stretches for approximately 280 miles in length and varies from 12 to 43 miles in width, with an imposing thickness of around 820 feet. During the Antarctic summer, which spans from November to late February, the surface of the ice shelf undergoes melting, giving rise to ribbon-like lakes of meltwater. These elongated bodies of water carve their way across the icy landscape, hence their descriptive name. But when iceberg A84 drifted away, it exposed a section of the ocean floor that had remained hidden from view, a pristine environment untouched by sunlight. The research vessel, Falor 2, operating nearby in the Bellinghausen Sea, recognized the unprecedented opportunity. Seizing this rare chance, they immediately altered their course. This was akin to lifting a long undisturbed stone in a primeval forest, revealing the hidden world teeming beneath. The scientists deployed an underwater robot named Sebastien, a technological marvel designed to explore the crushing depths. For 8 days, Sebastien plunged into the abyss, reaching depths of over 4,200 feet. There, illuminated by the robot's powerful lights, they discovered a thriving hidden ecosystem. Gigantic corals and sponges formed dense thickets, providing refuge for a myriad of sea creatures. It was a complete, self-sustaining world, flourishing beneath the ice. The research team anticipated finding some life, but the sheer abundance and diversity astonished them. This ancient underwater community wasn't merely surviving, it was prospering in this hostile, icy environment. Delicate anemones resembling miniature, fluffy trees swayed in the currents, alongside spindly sea spiders and elusive ice fish. Octopuses, their tentacles gliding through the water, patrolled the depths. The entire exploration was streamed live to scientists across the globe, the footage freely accessible for all to witness. Most remarkably, some of the creatures discovered appeared to be entirely new species, life forms unique to this isolated corner of the planet. This possibility stems from Antarctica's unique geographic position. For millions of years, the continent has been isolated from the rest of the world, encircled by the formidable Antarctic circumpolar current, a frigid moat guarding its icy secrets. Even if these creatures aren't entirely new to science, the expedition unveiled a stunning array of life. Snails, bristleworms, crustaceans like tiny crabs and shrimp, and most notably, a species of the elusive phantom jellyfish. These otherworldly beings are rarely seen, and their scientific name is so complex that they are more simply referred to as the giant phantom jelly. And giant it is. The bell, or umbrella-shaped body, of this jellyfish can exceed 3 feet in diameter. Trailing behind it are 4 ribbon-like arms, each stretching an astonishing 33 feet, roughly the length of a school bus. The first specimen was documented in 1899, but it took scientists 6 decades to recognize it as a distinct species. The phantom jellyfish boasts a translucent, purplish body, lending it an ethereal, ghostly appearance. Unlike typical jellyfish with tentacles, the phantom jelly possesses these ribbon-like arms, which it uses to ensnare prey and guide it towards its central mouth. Despite lacking a brain in the conventional sense, researchers observed surprising behavior in the giant phantom jelly. The creature seemed to move its arms with remarkable precision and control, especially when navigating through tight spaces on the seafloor. Its movements appeared cautious and deliberate, a testament to its adaptation to this challenging environment. Jellyfish possess a simple nerve net instead of a centralized brain, allowing them to perceive their surroundings. However, the phantom jelly's coordinated movements suggest a level of intelligence or coordination exceeding that of other jellyfish species. Studying this remarkable creature could unlock secrets about how animals without brains navigate, explore, and survive in complex underwater environments. Our exploration of the Antarctic depths yields a fascinating discovery. the humble bristleworm. Scientists classify them as polychaetes, but bristleworm is far more evocative. These creatures, in their diverse forms, thrive in the crushing cold and darkness of the ocean's abyss. Imagine them, bodies segmented like armored trains, each section adorned with tiny hair-like bristles. These aren't mere decorations. They are vital tools for movement, sensory perception, and even defense against the unseen dangers of their world. Consider, for example, the Antarctic scale worm. This particular species, a type of bristleworm, dwells in the frigid deep waters, its body shimmering with golden bristles, an unexpected touch of elegance in such a harsh environment. During their Antarctic deep-sea exploration, the team also stumbled upon colossal sponges, shaped like ornate vases. These sponges grow with agonizing slowness. The sheer size of these sponges suggests an immense age, potentially centuries. Their presence speaks volumes. The deep-sea ecosystem surrounding them is no recent phenomenon. These communities have existed for decades, flourishing beneath the icy shield. This truly is ancient life, concealed beneath the frozen surface, a revelation that has stirred considerable excitement among the scientific community. Previous investigations, which involved lowering cameras through boreholes or exploring areas recently exposed by iceberg calving, often revealed a barren landscape with only sparse signs of life. But this time, the team arrived a mere few weeks after a massive iceberg broke free, granting them a glimpse into the hidden world that lay beneath. The initial 9 miles behind the former ice shelf proved to be a haven for a vibrant and bustling ecosystem. Despite the perpetual darkness, the bone-chilling temperatures, and the long period of isolation, countless creatures have found a way to survive. This remarkable discovery underscores the resilience of life, its ability to persist even in environments that seem utterly inhospitable. Yet, in another sense, the abundance of life isn't entirely unexpected. The deep ocean, even without an icy lid, is home to a plethora of creatures adapted to darkness and cold. It stands to reason that similar communities would exist beneath the ice shelf, shielded from the world above. What truly puzzles scientists is the sheer diversity of species, thriving in what was once a completely isolated environment. It uncannily resembles the seabed in ice-free regions of Antarctica. How is this possible? Typically, life in the ocean's depths is supported by a chain that begins with phytoplankton, microscopic plants that flourish near the surface, bathed in sunlight. These plants are consumed by krill, tiny shrimp-like crustaceans, which then descend to the depths, delivering vital nutrients to the seafloor. Even their waste contributes to the sustenance of the deep-sea ecosystem. However, with a massive ice shelf overhead, sunlight is blocked, preventing plant growth and disrupting this crucial food supply. Scientists initially believed this would lead to a scarcity of food, and consequently, a limited number of animals. But the reality proved far different. It appears that food and nutrients are transported beneath the ice by underwater currents, akin to subterranean rivers. These currents, largely fueled by melting glacial water, carry enough sustenance to maintain a thriving and diverse ecosystem. The discovery of long-lived species further supports this theory. What the future holds for this hidden world, now that its icy roof has vanished, remains uncertain. These creatures have adapted to a stable, pitch-black environment over countless years, and they are unlikely to welcome change. The loss of their icy shelter could have profound and unpredictable consequences. One of the scientists noted that the ice shelf from which the iceberg originated has been retreating at a rate of approximately 25 meters per year over the past half-century. This retreat is part of a larger trend, the accelerating melting of Antarctic ice, which is contributing to rising sea levels worldwide. This Antarctic discovery underscores the profound importance of understanding and addressing these global changes. The team is currently piecing together not only the immediate activity within this hidden realm, but also its role within the grand scheme of things. If we can decipher the patterns of change occurring over decades, perhaps even centuries, we might just be able to anticipate what lies ahead. Isn't it remarkable that the cracking of ice can reveal so much? We often fill our world with music, podcasts, and the calming sounds of rain or a crackling campfire. But what about lending an ear to the ocean itself? Not the familiar roar of waves crashing against the shore, but the eerie sounds echoing from the cold, dark ocean floor. Sounds that can send shivers down your spine. Sounds hinting at something massive, shadowy, and possibly alive. And here's the truly unsettling part. The true nature of some of these sounds remains shrouded in mystery to this very day. Picture this. 1997. A strange sound reverberates through the Pacific Ocean. Deep beneath the surface, far off the coast of South America, a sound emerges with such immense power that it instantly alarms scientists. It was incredibly low in frequency, deafeningly loud, and utterly unlike anything ever recorded. This signal was simply named the bloop. At first hearing, the bloop might seem almost harmless, even playful. But the reality it suggests is far from it. The sound was so incredibly intense that it could be detected by sensors nearly 3,000 miles away. Imagine standing in London and hearing a sound originating from New York City. Now, imagine that sound traveling through the crushing depths of the ocean, sending ripples of fear through marine life and the minds of oceanographers. Whatever created it must have been absolutely colossal. The signal possessed patterns that suggested a living source. Whales were immediately suspected, but even the blue whale, Balænoptera musculus, the largest animal on our planet, simply couldn't produce a sound of that magnitude. The physics didn't align, and that's when speculation began to run wild. If something could generate the bloop, it would have to dwarf anything currently swimming in our oceans. People began to conjure images of creatures of unimaginable size, ancient sea monsters like the kraken. Some even whispered of the megalodon, Otodus megalodon, a prehistoric shark of monstrous proportions believed to have vanished millions of years ago. The mystery deepened when scientists pinpointed the approximate origin of the sound. It seemed to emanate from a region near Point Nemo, the most isolated location on Earth. This spot in the Pacific Ocean is more than 1,000 miles from any landmass in any direction. Its extreme isolation has earned it the title of the Oceanic Pole of Inaccessibility. Point Nemo is a place that few humans will ever witness. Its remoteness has made it a kind of watery graveyard for defunct satellites and discarded space debris. When spacecraft are retired, they are often directed to plunge into these waters. It's a silent, desolate, almost untouched realm. And yet, something incredibly powerful had roared from nearby. For enthusiasts of cosmic horror, this detail has an unsettling familiarity. In the fictional world crafted by writer H.P. Lovecraft, the ancient sunken city of R'lyeh lies beneath the ocean in this very region. According to his tales, R'lyeh is the prison of Cthulhu, a monstrous entity of immense power slumbering for millennia, poised to awaken and usher in the end of the world. Of course, Cthulhu is a figment of imagination. Lovecraft never claimed otherwise. However, once the internet drew the connection, the idea took on a life of its own. But science, as it often does, eventually caught up. The bloop recording remains readily accessible online. You can listen to it yourself, but its innocuous nature might leave you wanting. Today we know with certainty that it didn't originate from a living creature. Researchers later confirmed that the sound... Imagine the crushing weight of a colossal iceberg, a frozen leviathan, as it groans under immense pressure. Then, with a cataclysmic shudder, it fractures. This is no ordinary crack. It's an icequake, a seismic event born of ice. When these gargantuan icebergs calve, when they splinter and break free from the glacial embrace, they unleash unimaginable energy. This energy manifests as ultra-low frequency sound waves, vibrations that resonate across entire ocean basins. These sounds, traveling vast distances through the water, become distorted, almost unrecognizable. It's an eerie phenomenon. Remarkably, these glacial groans bear a resemblance to biological calls, especially when heard from afar. Scientists, captivated by the mystery of the bloop, meticulously compared its sonic signature to known icequake recordings. They found striking similarities. The truth, while less sensational than a sea monster, was no less awe-inspiring. The bloop was Antarctica itself, shifting, breaking, and reshaping its icy form. For some, this explanation brought a sense of disappointment. On online forums, Many confessed a preference for the idea of a colossal, unknown life form lurking in the deep. The allure of the unknown, it seems, is a powerful draw. But the ocean holds more mysteries. Fast forward to the early 1980s. A scientific expedition ventures into the South Pacific, near New Zealand, exploring the South Fiji Basin, AES realm where the ocean floor plunges more than 2.5 miles into the abyss. Here, amidst the crushing pressure and eternal darkness, they encountered something truly bizarre. Short, sharp, repeating noises echoing through the water. These were no ordinary sounds. 4 distinct bursts, each one sounding uncannily like a duck's quack. The researchers, amused and intrigued, dubbed it the bioduck. The sound was rhythmic, consistent, a steady pulse in the ocean symphony. The team concluded that the source had to be biological, some unknown creature lurking in the depths, but identifying the culprit proved impossible. What strange animal was responsible for this aquatic quacking? After sharing their data with colleagues in Australia, an even stranger realization dawned. Similar sounds had been recorded in other parts of New Zealand and Australian waters. The mystery deepened. Decades later, the bioduck remains an enigma. Some scientists speculate that these quacks may not be random at all. Perhaps they are a form of communication, a language spoken in the deep. Could they be the calls of Antarctic minke whales, Balænoptera bonarensis, though concrete proof remains elusive? Adding to the intrigue, scientists noted that multiple sources of these sounds existed. And when one source spoke, the others fell silent, as if listening intently. Imagine a conversation echoing through the abyss, a language we are yet to decipher. Now picture this. A piercing alarm blares within a clandestine laboratory, signaling the escape of a monstrous being from another world. An ugly, oppressive sound that makes your skin crawl. In August 1991, scientists recorded something eerily similar, not in a lab, but deep beneath the Pacific Ocean. Across vast expanses of the ocean, a strange, repeating signal began to materialize at various times. It consisted of narrow, rising tones, each lasting several seconds. Researchers christened this sound upsweep. Upsweep is most frequently detected during the spring and fall, leading scientists to hypothesize a connection to seasonal environmental shifts or changes within the sound source itself. But what exactly is producing it? The truth remains shrouded in mystery. The only certainty is that upsweep appears near areas of suspected volcanic activity. But if this sound is natural, why does it possess such precision, such consistency? It almost feels artificial, as if a secret underwater facility is periodically broadcasting a distress signal from the ocean's depths. Since its initial discovery in 1991, the upsweep signal has gradually weakened, making it one of the most peculiar and unexplained phenomena ever documented beneath the waves. And then there's another mysterious sound, known simply as slowdown. True to its name, this signal steadily decreases in frequency over a 7-minute period before fading into complete silence. It was recorded in May 1997 by a hydrophone array situated in the eastern equatorial Pacific Ocean. At first glance, slowdown doesn't seem particularly loud. But here's the chilling detail. It was picked up by 3 separate sensors positioned nearly 300 miles apart. Imagine the sheer, earth-shattering power of the source itself. The sound must have been absolutely deafening, a terrifying experience for any creature that happened to be nearby. But what cataclysmic event could have possibly generated such a noise? The most accepted explanation involves a gargantuan iceberg, a drifting mountain of ice, slowly grinding to a halt as it ran aground on the ocean floor. It's a surprisingly believable scenario. Picture a colossal block of ice, its submerged mass scraping against the seabed, relentlessly pushing forward until it finally comes to a complete stop. The location of the sound supports this theory, as it originated near relatively shallow waters and small, isolated islands. Because of these factors, many scientists categorize bloop, along with similar sounds, as a cryogenic noise, a sound produced by ice. However, it's crucial to remember that this remains just a theory. Officially, the true source of the sound has never been definitively identified. The ocean's depths continue to guard their secrets. And there's yet another unsettling recording from the deep. This one evokes the image of a mournful moan, yet scientists have simply named it whistle. Go figure. Recorded in 1997, this sound creates the disturbing impression of some immense creature, perhaps larger than any whale, sitting on the ocean floor and emitting a long, drawn-out whistle. Researchers believe that the source might be an underwater volcano. When they compared the whistle signal to previously recorded sounds of volcanic activity in the eastern Pacific, they discovered striking similarities. In all likelihood, these mysterious sounds originate from natural phenomena, volcanic eruptions, or the grinding groaning of colossal icebergs. But even with a rational explanation, it's still chilling to imagine hearing such sounds while sailing on the open ocean. It would be an utterly terrifying experience to find yourself directly above an erupting underwater volcano. Tragically, over 1,500 souls perished in this very part of the ocean. Perhaps it's a wise decision to keep a respectful distance. The location where the RMS Titanic met its end remains a hazardous place. Yes, enormous icebergs still roam those waters, but even greater dangers lurk beneath the surface, unseen. The Titanic rests approximately 2,500 feet below the waves, roughly 400 miles southeast of Newfoundland. Having been submerged for over a century, the wreck is slowly succumbing to the relentless forces of the deep. The legendary ship is rusting away, just as any iron or steel structure would in the harsh underwater environment. Chemically speaking, the combination of iron, oxygen, and water triggers a reaction that creates iron oxide, the very essence of corrosion. The steel plates, the massive support beams, and all the ship's iron components are gradually weakening. Sections of the liner are collapsing, like the ceiling in the captain's bathroom and a portion of the railing that gave way not long ago. But in the case of the Titanic, much of the corrosion is accelerated by iron-eating bacteria. When the Titanic sank, it broke into two major sections, the bow and the stern. These pieces came to rest nearly 2,000 feet apart on the ocean floor. Today, both sections are enveloped in a thick biofilm, a living carpet composed of bacteria, marine fungi, and countless other microorganisms. Over time, these microbes, feeding on the ship's iron, have created formations known as rusticles. These rusticles are, in fact, accelerating the decay of the wreck. Scientists have observed that the stern is disintegrating at a significantly faster rate than the bow, largely due to the greater structural damage it sustained during the sinking. And now, thanks to the relentless activity of these bacteria, the stern could be deteriorating as much as 40 years ahead of the bow. Down in the crushing depths, these microbes are thriving. If you have a phobia of germs, this might sound like an absolute nightmare, but it's not as bad as it seems. For one thing, these rusticles don't even look repulsive. They actually possess a strange beauty, resembling delicate ice crystals or tiny diamonds clinging to the skeletal remains of the ship. And rest assured, you are not in any real danger. As long as you maintain a safe distance from the wreck, avoid direct contact, and definitely refrain from poking around inside, there is virtually no risk. Speaking of getting dangerously close, we can't ignore the tragic story of the Titan submersible disaster. The submersible that suffered a catastrophic implosion in 2023 during a voyage to the Titanic wreck. Sadly, all 5 people, and tragically, all souls aboard were lost to the unforgiving sea. Imagine, if you will, the sheer audacity of descending over 2 miles into the crushing depths. What was marketed as a tourist adventure was, in reality, a perilous undertaking. A descent into a realm of absolute darkness, chilling cold, and unfathomable pressure. Sunlight, the life-giver, is swallowed by the water long before reaching such depths, ceasing its reach beyond a mere 3,300 feet. Below that point stretches the midnight zone, an eternal abyss. The Titanic rests within this lightless domain. Those few who have braved this journey speak of a descent lasting over 2 hours, a slow fall through an impenetrable blackness. Then, seemingly from nowhere, the ocean floor bursts into view, illuminated only by the submersible's artificial lights. But finding the wreck itself presents another monumental challenge. Navigation at such depths is a daunting task. Reaching the bottom is only the beginning. Pinpointing your exact location becomes a desperate game of hide and seek. You're essentially groping in the dark, knowing that the ghostly remains of the Titanic loom somewhere nearby, yet hidden from view. Thankfully, the explorers had a crucial advantage: meticulously detailed maps of the Titanic's site, painstakingly compiled from decades of high-resolution sonar scans. As the ghostly wreck begins to materialize from the gloom, these maps become invaluable guides, keeping the submersible on course. Advanced sonar and sensors act as the vessel's extended eyes, detecting features and objects far beyond the reach of its feeble lights. The Titan submersible, for example, was equipped with a Doppler velocity log. This ingenious device emitted sound waves, measuring the submersible's speed and depth by calculating its distance from the seabed. Despite these technological marvels, veterans of previous Titanic expeditions have recounted the immense difficulty of navigating the treacherous terrain of the ocean floor. And then there's the crushing pressure, an ever-present threat in this alien world. For every foot of descent, the weight of the water increases exponentially. At the Titanic's resting place, the pressure is simply mind-boggling, roughly 200 times the pressure inside a car tire. This is why submersibles require incredibly robust, super-thick hulls to withstand the immense forces. So, the environment surrounding the Titanic is a bizarre and hostile cocktail of flesh-eating microbes, perpetual darkness, and bone-crushing pressure. But there's another, more subtle force at play: unpredictable underwater currents. We've all experienced the familiar tug of currents when swimming in the ocean. But the deep ocean possesses its own unique hidden currents. Though generally weaker than those on the surface, they are still capable of moving colossal volumes of water. These deep-sea currents are driven by a variety of factors, including wind patterns, variations in water temperature and salinity, and even bizarre, localized storms known as benthic storms that erupt on the ocean floor. These benthic storms can be surprisingly violent, churning up the seabed and creating underwater havoc. As we know, the Titanic wreck lies in two main sections, the bow and the stern. Researchers have been meticulously studying the seabed in the surrounding area, and their findings reveal a complex interplay of currents. One section of the wreck lies near a frigid underwater current known as the Western Boundary Undercurrent. This current flows southward, carrying mud and sand along the ocean floor, sculpting ripples and patterns that reveal its strength and direction. Most of the time, these currents are relatively gentle. Scientists have even discovered delicate sand ripples near the debris field, where scattered remnants of the Titanic, furniture, coal, and countless personal items came to rest. These ripples indicate a current flowing from east to west. However, within the main wreck site itself, conditions become far more turbulent. The water flow shifts erratically from northwest to southwest, likely due to the massive, fragmented sections of the ship disrupting the natural flow. Around the southern edge of the Titanic's bow, the currents become particularly unpredictable, veering from northeast to northwest and even southwest. It's as if the ocean is simply doing as it pleases, regardless of our attempts to understand it. Experts believe that, over countless years, these ever-shifting currents will slowly but surely bury the Titanic beneath layers of sediment, of mud and sand, slowly dissolving into the seabed. Imagine the wreck, bit by bit, succumbing to the relentless embrace of the ocean floor, fading from existence. Now, let's address the elephant in the room, or rather, the iceberg in the ocean. Icebergs remain a very real threat to maritime navigation, even today. As recently as 2023, a staggering 380 icebergs drifted into the busy shipping lanes connecting North America and Europe. That's a chilling statistic. You see, the larger the iceberg, the easier it becomes to spot on radar and avoid. But smaller icebergs are far more difficult to detect, lurking just beneath the surface. And they are no less dangerous. In fact, the true peril lies beneath the waves, in the unseen mass hidden from view. Consider the iceberg that tragically sank the Titanic. Passengers witnessed a mere 100 feet of ice above the water, but it's estimated that this was only about 16% of the iceberg's total mass. Experts believe the remaining portion, hidden beneath the waves, extended hundreds of feet deeper, a colossal menace unseen. The good news is that, unlike in the Titanic's era, we now possess advanced technology to detect icebergs in advance. Modern ships are equipped with radar and satellite imagery capable of identifying icy threats lurking even in the darkest conditions. Some vessels even employ sonar and thermal imaging to penetrate through dense fog, aiding the crew in spotting icebergs above the surface. GPS and AIS systems help ships navigate safer routes, while monitoring centers across the globe issue real-time alerts, essentially acting as a personal iceberg spotting assistant. It's a monumental leap from relying solely on binoculars. So, you likely won't have to worry about icebergs on your next cruise, even if it follows the Titanic's path. But just to be safe, perhaps avoid traveling with anyone named Jack or Rose. And, under no circumstances, should you play the violin while on board? Just a friendly suggestion. Ooh, you're plunging into the dark, icy depths of Antarctica. An eerie blue darkness surrounds you, reminiscent of the vastness of outer space. Here, in these frigid depths, where you least expect to encounter life, you suddenly hear a loud, peculiar sound, a quacking noise, as if a colossal duck were concealed in the abyss. In 1960, researchers first documented this sound, aptly naming it bioduck. For decades, they embarked on a quest to unravel its origin. Was it a gigantic kraken, the mythical sea monster? An extraterrestrial spacecraft that crash-landed into the ocean? Or perhaps a truly enormous duck? Theories abounded, each more outlandish than the last. Oceanographers detected similar sounds in other locations as well. Off the western coast of Australia and near New Zealand, they recorded similar but higher-pitched signals, dubbed biogoose. These sounds were not isolated incidents. They occurred repeatedly at consistent intervals. Initially, many suspected a mechanical source, given the regularity of the sounds. However, studying the oceans in the latter half of the 20th century presented significant challenges due to limited technology. Nevertheless, driven by their boundless curiosity, scientists persisted in gathering data on bioduck and biogoose. As more data accumulated, so did the theories. But eventually, scientists uncovered the mystery. Bioduck turned out to be a form of communication with a biological source. When researchers analyzed the repeating sounds, they noticed that the signals never overlapped. One source would speak, while the others remained silent, hinting at a complex form of communication. The question remained, what ocean creature possessed such an extraordinary method of communicating through varied frequency sounds? The answer, as many may have guessed, is whales. Scientists compared the bioduck sounds from Antarctica to the calls of minke whales, Balænoptera acuta, and discovered striking similarities. The biogoose sounds from the waters of Australia and New Zealand likely belong to other species, or perhaps very young minke whales. But the mystery only deepened from there. What could these enigmatic calls possibly signify? Were these colossal marine mammals perhaps strategizing their next meal, sharing a private chuckle at the expense of the human observers, or even contemplating the profound secrets of the cosmos? The possibilities stretched as vast and deep as the ocean itself. Yet the most mind-blowing possibility of all loomed large. The potential for humans to one day bridge the communication gap with these awe-inspiring creatures. And that day may be closer than we think. The once unthinkable notion of conversing with whales has edged closer to reality. Scientists at the University of California have seemingly cracked the code, initiating a dialogue with a humpback whale known affectionately as Twain, Megaptera novaeanglii. In an experiment that could redefine our understanding of interspecies communication, researchers engaged in a 20-minute exchange with this denizen of the deep. The procedure was as follows. The team of specialists embarked on a marine expedition to the Alaskan coast, their mission to capture the acoustic tapestry of a humpback whale pod. Armed with sensitive recording equipment, they meticulously documented the whale's vocalizations. Next, they broadcast these recorded sounds back into the ocean depths, using underwater speakers to project the signals. These carefully selected sounds bore a striking resemblance to a greeting. Hey, what's up? Rendered in the intricate language of whales. Such greetings serve as a means for whales to identify themselves, call out to one another, or broadcast their location across the vast oceanic expanse. Astonishingly, the research team received a prompt reply to their aquatic overture. Twain, as if drawn by an invisible thread, approached the research vessel, circled it with curiosity, and responded with a hey of its own. This marked the dawn of an unprecedented era, the first documented instance of interspecies conversation between humans and a whale. For a continuous 20 minutes, the scientists transmitted a series of 36 distinct signals to Twain, and each time, the whale responded in kind, showcasing an uncanny understanding of the exchange. Even more remarkable, Twain demonstrated a sense of timing, deliberately pausing for measured intervals before offering its reply. The team would send a signal, receive Twain's response, then wait a precise 10 seconds before initiating the next transmission. Twain mirrored this behavior, maintaining a consistent 10-second pause before answering, indicating a clear understanding of the conversational rhythm. It seemed that Twain was a very delicate interlocutor, a true gentleman of the sea. Perhaps it was a gentleman in the whale world. Who knows? Or perhaps, more simply, it was captivated by the sheer novelty of the interaction, intrigued by the unusual sounds emanating from the strange surface dwellers. The signals employed in this aquatic conversation were drawn from the existing repertoire of Twain's pod. In essence, the researchers had likely captured Twain's own vocalizations and repurposed them to initiate the dialogue, creating a scenario where, in a sense, Twain was conversing with its own echo. Now, let us shift our focus and plunge into the inky blackness of the Mariana Trench, the ocean's deepest abyss. As a quick reminder, the Mariana Trench is a colossal scar upon the ocean floor, an immense canyon stretching over 1,500 miles to the south of Japan. At its deepest point, it plummets to an astonishing 36,000 feet. To truly grasp the scale of this underwater wonder, consider this. The Burj Khalifa, the tallest building ever erected by humankind, would only reach a mere tenth of the Mariana Trench's total depth. Now, let your imagination run wild. Picture this. In this lightless, crushing environment, scientists have recorded a sound unlike any other. Unlike the bioduck recording, this sound evokes the realm of science fiction, an alien echo in Earth's deepest realm. A deep, resonant rumble, followed by a metallic ping, a soundscape eerily reminiscent of the sonic signatures of spaceships from the silver screen. Researchers, captivated and mystified, christened this enigmatic phenomenon biotwang noises. The first detection of this bizarre sound occurred in 2014 during an acoustic survey of the Mariana Trench. Scientists swiftly traced the source to a surprising origin. Whales, specifically. Bride's whales, Balænoptera edeni. Leveraging the power of artificial intelligence, researchers meticulously analyzed approximately 200,000 hours of underwater audio recordings, ultimately pinpointing matches within the vocalizations of a bride's whale pod. Like many other creatures inhabiting our planet, these whales rely on sound as a fundamental means of communication, weaving intricate acoustic tapestries to navigate their world. Now, would you believe what else has been discovered in the crushing depths of the Mariana Trench? A plastic bottle. It's highly improbable that this piece of refuse was deposited by a kraken, a whale, or some other mythical sea monster. The explanation is far more mundane and far more troubling. The bottle's presence is a direct consequence of human activity, but that grim reality is a story best saved for another time. Instead, let us turn our attention to one final haunting sound. This time, no whales are involved, only an unsettling sonic mystery emanating from the most isolated place on the face of the Earth. This forsaken location is known as Point Nemo, and its isolation is precisely what makes it so unique. Situated in the vast expanse of the South Pacific Ocean, Point Nemo is... Imagine a place more isolated than any other on Earth. Picture the most remote spot imaginable, far removed from human contact. This is Point Nemo, a location so distant from land that the nearest island lies a staggering 1,450 nautical miles away. In every direction, the distance to shore is almost identical, a truly lonely place on our planet. But the isolation doesn't end there. This oceanic void is practically devoid of marine life. Few currents reach these waters, meaning vital nutrients are scarce. It's a true aquatic desert, a seemingly lifeless expanse. Then, in 1997, something extraordinary happened. Oceanographers using underwater microphones detected a bizarre and unsettling sound emanating from the depths near Point Nemo. This sound was unlike anything they had ever encountered, something immense, something frightening. They dubbed it the bloop. The name alone conjures images of colossal deep-sea creatures. As news of this mysterious sound spread, journalists picked up the story, and speculation ran wild. The most popular theory, fueled by our primal fears, was that the bloop was the vocalization of a giant sea monster, perhaps a kraken of legend, or some other unimaginable leviathan lurking in the abyss. The frenzy surrounding the bloop was intense, but thankfully short-lived. Science, as it often does, stepped in to unravel the mystery. Researchers eventually determined that the source of the sound was far less terrifying, but no less impressive. An iceberg. When icebergs crack and break apart, they unleash tremendous energy, creating powerful ultra-low-frequency sounds that can travel vast distances through the ocean. To confirm their hypothesis, scientists recorded the sounds of other icebergs breaking, and the results were conclusive. They produced sounds remarkably similar to the bloop. Now consider the sheer remoteness of Point Nemo. It's so isolated that space agencies use it as a dumping ground for decommissioned satellites. These defunct spacecraft are intentionally guided to splash down in this area, with a calculated 99% certainty that no marine life or humans will be harmed by the falling debris. It's a cosmic junkyard, earning the nickname the Satellite Cemetery. But what if, someday, a spacecraft from another world were to fall into Point Nemo's watery depths? What if such an alien vessel has already crashed there and occasionally emits a distress signal that reverberates through the ocean, a signal we might mistake for something else entirely? A chilling thought, indeed. While the mysteries of the bloop and the satellite cemetery have been solved, the ocean still holds secrets that defy explanation. Let's turn our attention to a sonic enigma that continues to baffle scientists. Upsweep. Upsweep is not merely noise, it's a distinct series of sharp ascending tones, repeated at intervals of several seconds. It was first detected in 1991 using hydrophones strategically placed in the Pacific Ocean. Initially, oceanographers proposed that upsweep might be linked to volcanic activity or underwater earthquakes. However, the seasonal nature of the sound and the way its intensity fluctuates throughout the year effectively ruled out these geological explanations. The focus then shifted to the biological realm. Researchers began to investigate the migration patterns and behaviors of marine animals at different times of the year, hoping to find a connection to the upsweep sound. Despite extensive efforts, the source of upsweep remains elusive. Some studies suggest that it may be associated with specific species of fish or other marine creatures that use sound for communication or navigation. Yet conclusive proof remains out of reach. The mystery of upsweep endures. Time for a quick quiz to test your knowledge. What is the strongest river in the world? The Amazon, you might say? A reasonable guess, but far from the truth. The most powerful river on our planet isn't on land at all. It flows beneath the surface, an unseen force of nature known as the Antarctic Circumpolar Current, or the ACC. This colossal current dwarfs the Amazon in terms of sheer power, flowing with a force 100 times greater. To put that in perspective, the energy contained within the ACC could power over 100,000 hydroelectric plants, enough electricity to illuminate entire continents. But the ACC is more than just a display of raw power. It's a critical component of Earth's climate system, acting as a thermostat, a carbon sink, a climate stabilizer, and an oceanic superhighway, all rolled into one. Now, for the unsettling news. Scientists have observed a disturbing trend. The ACC is slowing down, and the rate of deceleration is alarming. Projections suggest it could weaken by as much as 20% by the year 2050. If this trend continues, the consequences could be catastrophic, leading to climate disruptions that would make even the most challenging days seem trivial by comparison. So, is it time to panic? Well, before we jump to conclusions, let's delve deeper and understand the intricate workings of the ACC. What exactly is this underwater behemoth, and why is it so vital to the health of our planet? To truly understand the stakes, we need to plunge into the depths of the ocean, metaphorically speaking, of course. The Antarctic Circumpolar Current, ACC, a phenomenon unlike any other, is the only oceanic current that relentlessly circles the entire globe. Imagine it as a colossal river, a frigid belt of water perpetually embracing the icy continent of Antarctica. Unlike its counterparts, which are often disrupted by landmasses, the ACC boasts an unobstructed path, a clear aquatic racetrack with nothing but open ocean in its way. This allows it to surge, uninterrupted, through the narrow Drake Passage, squeezed between the tip of South America and the frozen landscapes of Antarctica. The sheer volume of water it transports is staggering, a mind-boggling 3.6 billion cubic feet every single second. It's a quantity so immense that comparisons fail us. Fueled by relentless westerly winds that perpetually howl eastward, the ACC acts as the vital link, seamlessly connecting the Atlantic, Pacific, and Indian Oceans into a single unified supercurrent. But its influence doesn't stop at the surface. It plummets into the inky blackness of the abyssal depths, forging connections between the shallow, intermediate, and deep waters, stirring them all together in a colossal, swirling vortex of oceanic energy. In the simplest terms, though perhaps it's already too late for simplicity, the ACC is the very glue that holds our planet together. It plays a leading role in the thermohaline circulation, also known as the global conveyor belt. This is the system responsible for redistributing heat, carbon, and essential nutrients across the entire planet. To keep this intricate system functioning, the ACC drives nutrient-rich water from the deep up towards the surface in a process called upwelling. This upwelling feeds the foundation of the marine food web, plankton, krill, whales, and ultimately the seafood on our plates. If you cherish seafood or even care about the health of the ocean's delicate food chains, it's time to pay attention. Without this continuous cycling of nutrients, marine life, from the smallest organisms at the bottom to the apex predators at the top, would suffer immensely. Now, for the truly fascinating part. While diligently serving as the ocean's waiter, the ACC also takes on the role of Earth's laundry service, in a way. It absorbs astonishing quantities of carbon dioxide from the atmosphere, effectively trapping and storing it within the deep ocean for centuries. Visualize it as Earth's gigantic carbon vault, requiring no password for entry. Furthermore, the ACC plays a pivotal role in regulating our planet's weather patterns. Without its constant movement of heat around the globe, Western Europe would experience a drastic temperature drop of roughly 50 degrees Fahrenheit. Imagine Paris transformed into a Siberian landscape, and Londoners swapping their umbrellas for snowshoes. The current acts as a stabilizer, maintaining the delicate temperature balance between the hemispheres and influencing wind patterns, rainfall distribution, and overall ocean temperatures worldwide. Even the behavior of hurricanes could be dramatically altered because warm ocean surfaces are a crucial ingredient in their formation. Tampering with the currents could unleash stronger, more unpredictable storms. So, what's causing this vital current to slow down? The answer, unsurprisingly, lies with human activity. Consider the melting ice caps. In Antarctica, the home of our friend the ACC, the ice sheets hold such a massive volume of water that if they were to completely melt, global sea levels would rise by more than 200 feet, towering over even Cinderella's castle. To make matters worse, a staggering 60% of the world's fresh water is locked away within this ice. While the sheer quantity of melting water is alarming in itself, it's the freshwater's impact on the ocean's salinity that poses the greatest threat. The ACC relies on the cold, highly saline water of the Southern Ocean to be dense and heavy, enabling it to sink. This sinking motion is what helps drive the current forward, creating a continuous chain reaction. However, As fresh water from melting glaciers pours into the ocean, it dilutes the saltiness, reducing the water's density and hindering its ability to sink properly. Without this crucial sink and flush mechanism, the ACC struggles to maintain its powerful flow. It's akin to trying to flush a toilet in zero gravity. As this process continues, the influx of fresh water spreads northward, disrupting the ocean's density structure and counteracting the effects of ocean warming, which would typically accelerate the current. Instead, the ACC grinds to a halt. A weakened ACC translates to less upwelling, meaning fewer vital nutrients reach the surface. This could have catastrophic consequences for Antarctic marine ecosystems, leading to a decline in biodiversity, the collapse of fisheries, and the endangerment of iconic species like penguins. The consequences are dire, impacting every level of the food chain, from whales to krill. Imagine the delicate balance in Antarctica, now threatened by invasive species like the southern bull kelp. This seemingly harmless plant could trigger a catastrophic collapse, throwing the entire ecosystem into disarray. Krill, the tiny crustaceans, form the cornerstone of the Antarctic food web, sustaining whales, seals, penguins, and countless fish species. A krill population crash would send shockwaves throughout the system, causing it to teeter like a house of cards in a raging hurricane. But the nightmare doesn't end there. A terrifying feedback loop looms. As the Antarctic circumpolar current, ACC, weakens, warmer waters infiltrate the region, accelerating the melting of ice. This deluge of fresh water further weakens the current, leading to even more ice melt. A vicious cycle, spiraling out of control. Even more alarming, the warm waters erode ice shelves from below, causing them to disintegrate rapidly, even when surface temperatures appear stable. The global repercussions would be felt far and wide. Monsoons in India could become unpredictable, rainfall in the Amazon could dwindle, and agriculture across Africa and Asia could suffer devastating blows. Sea levels along the east coast of North America could surge dramatically, and global weather patterns could descend into chaos. The Southern Ocean's ability to sustain commercial fisheries, such as Chile's thriving salmon industry, could diminish as vital nutrients fail to reach the surface. And let's not overlook the crucial role of the ACC in absorbing carbon and excess heat. Without a strong current, the ocean's capacity to perform this function plummets. More CO2 and heat would remain trapped in the atmosphere, exacerbating the already dire situation. It's akin to switching off Earth's air conditioner while simultaneously cranking up the furnace and setting fire to the pantry. Of course, this isn't the first instance of oceanic currents behaving erratically. Before human-induced climate change, Earth experienced a period of intense cold known as the Little Ice Age. But there's more to it than just colder winters. This frigid episode may have been triggered by anomalies in the ocean currents of the North Atlantic. Not so long ago, the peak of this mini ice age occurred in 1850, practically yesterday in geological terms. Scientists hypothesize that melting glaciers and massive outflows of Arctic sea ice flooded the ocean with fresh water. This influx disrupted the ocean's delicate balance of salinity and density, weakening powerful systems like the Atlantic Meridional Overturning Circulation, AMOC, a crucial component of the global oceanic conveyor belt. As these currents slowed, less warm water reached the north, sea ice expanded, and temperatures plummeted further. And here's the unsettling part. Records from seashells near Iceland reveal that this shift wasn't sudden. It occurred in two distinct waves, as if the planet struggled to maintain equilibrium before succumbing to a colder state. The AMOC, being an integral part of Earth's complex life support system, is interconnected with everything else. Both systems are influenced by temperature, salinity, and the sinking of cold water. When the ACC weakens, it can disrupt the formation and mixing of deep water, potentially weakening the AMOC as well. It's a catastrophic domino effect to contemplate. Some models suggest that if both the ACC and AMOC are pushed beyond their tipping points, the result could be centuries of erratic climate conditions, far exceeding the capacity of modern agriculture and infrastructure to cope. So, the next time you savor a cold beverage or enjoy sushi, perhaps consider raising a toast to the mighty ACC. It's providing far more benefits than you realize, and it desperately needs our appreciation and a reduction in ice melt. Oceans encompass approximately 70% of Earth's surface, yet we've only explored a meager 5 to 20% of their depths. Astronomers have recently discovered an immense reservoir of water in space, located near a quasar over 12 billion light-years away, showing how much more there is to discover beyond our own planet. Imagine a volume of water so vast it dwarfs anything we can comprehend on Earth. We're not talking about a lake or even an ocean. This is a cosmic reservoir holding approximately 140 trillion times the total water volume of all Earth's oceans combined. An absolutely mind-boggling quantity. This colossal water cloud isn't floating freely in space. It's swirling around a supermassive black hole, a behemoth that tips the scales at 20 billion times the mass of our own sun. This black hole resides at the heart of an incredibly luminous quasar, radiating energy equivalent to 1,000 trillion suns. A number so large, it defies human comprehension. Because light takes time to traverse the vast distances of space, we observe this quasar as it existed in the universe's infancy. Astronomers believe this newly discovered water reservoir represents the most distant and largest ever found in the cosmos. According to Mark Bradford of NASA's Jet Propulsion Laboratory, the unique conditions surrounding this quasar enable the creation of such staggering amounts of water. Bradford and his team, along with other astronomers, have been intensely studying this quasar and its central supermassive black hole. They have observed that as the black hole gravitationally devours surrounding matter, it heats the surrounding gas and dust to extreme temperatures. This process has forged a region teeming with molecules never before observed at such immense distances. Quasars were initially detected around 50 years ago, when telescopes picked up extraordinarily bright objects from the farthest reaches of space. These aren't ordinary stars. They are powerful energy sources situated at the centers of distant galaxies, so potent they can outshine all the stars within their host galaxy combined. At the core of every quasar lies a supermassive black hole, possessing a mass millions or even billions of times greater than our sun. As gas and dust spiral into the black hole's gravitational maw, they are superheated, releasing colossal amounts of energy. This makes quasars some of the most luminous and powerful objects known in the observable universe. Observing quasars is akin to peering back in time. The light reaching us today has journeyed for billions of years, providing scientists with a glimpse into the universe's distant past. Quasars offer insights into galaxy formation, the distribution of matter, and the assembly of the earliest cosmic structures. Some quasars eject immense jets of superfast particles that stretch across vast stretches of space, potentially reshaping entire regions of the universe. But let's return to the topic of space water, or more accurately, water vapor. Upon its discovery, this vapor was found to be enveloping the quasar, extending across an area hundreds of light-years in diameter. To put that in perspective, a single light-year equals roughly 6 trillion miles. Although the gas is incredibly rarefied compared to Earth's atmosphere, it's significantly warmer and denser than the gas found in most galaxies, including our own Milky Way. The gas temperature hovers around 63 degrees Fahrenheit, and its density is about 300 trillion times less than Earth's atmosphere. Even by space standards, these are truly extreme conditions. The presence of water vapor near the quasar indicates that the area is constantly bombarded with intense radiation, which accounts for the gas's elevated temperature. Adding to the intrigue, astronomers have also identified carbon monoxide and other molecules, indicating a wealth of raw materials in the vicinity. In the future, this gas could fuel the supermassive black hole's growth, potentially increasing its size up to 6-fold. However, this is just one potential scenario. Some of the gas might be swallowed by the black hole, some might coalesce to form new stars, and some might be ejected into the depths of space. The discovery of water vapor in such a distant quasar suggests that the fundamental building blocks of the universe have existed for billions of years. Given water's essential role in life as we know it, its presence in the early universe hints that the fundamental ingredients. Life, as it turns out, emerged far earlier in the cosmos than we previously conceived. But water's significance extends beyond merely sustaining life. It is also a crucial element in the birthing process of stars and galaxies. Imagine vast clouds of gas, gradually cooling. Water steps in, facilitating their collapse and accelerating the formation of new stars, celestial newborns igniting in the darkness. But how did researchers manage to pinpoint this colossal cloud of water in the first place? Back in 2008, Bradford's team embarked on a quest to locate water in the vast expanse of space. They wielded a specialized instrument known as Z-spec, mounted on a 33-foot telescope perched high in Hawaii. To ensure the accuracy of their findings, they employed another formidable tool: a network of radio dishes nestled in the mountains of Southern California, collectively named Karma. Simultaneously, another team was conducting a parallel search for water, utilizing a telescope situated in the French Alps. In 2010, this second team detected a faint signal emanating from a distant quasar, a mere whisper of water. However, it was enough. Subsequently, Bradford's group detected more signals, solidifying the evidence and leading to the conclusion that an immense reservoir of water indeed existed out there, adrift in the cosmic sea. Now, this floating cloud of water vapor isn't the only place where we've discovered water beyond our own planet. Scientists have recently unveiled a groundbreaking discovery. Massive reserves of liquid water lie hidden beneath the surface of Mars. Picture this: future astronauts potentially tapping into these Martian aquifers to support their missions, perhaps even establishing a permanent foothold on the red planet. However, as always, there's a catch. This Martian water isn't conveniently located in easily accessible lakes or oceans. It's buried deep within the planet's crust, beyond the reach of our current technology. Scientists deduced its presence by analyzing seismic data transmitted by the Mars InSight lander. The lander detected unusual seismic activity, which could best be explained by the existence of these hidden water reservoirs. Mars still possesses some water today, primarily in the form of ice at or just below the surface. But this is a mere fraction of the vast quantities of water that the planet held billions of years ago. The great enigma remains. Where did all that water vanish to? Scientists speculate that it either escaped into space, gradually dissipating into the void, or migrated into the planet's interior, where it now resides as liquid reservoirs or ice deposits. The challenge lies in our inability to measure the precise amount of water that Mars has lost. For now, this question remains unanswered, a tantalizing mystery in the ongoing exploration of the red planet. Even our own moon harbors water, though not in the familiar forms of lakes or rivers. Instead, the lunar water exists primarily as frozen ice, unevenly distributed across the surface. The perpetually shadowed polar regions are particularly rich in ice, as they never receive direct sunlight. Much of this ice is also intermingled with the lunar soil and buried deep underground, making it incredibly difficult to access. Then there's Enceladus, one of Saturn's moons. A tiny world, a mere 312 miles in diameter, small enough to fit comfortably within the borders of Arizona. When NASA's Cassini space probe arrived at Saturn, scientists anticipated encountering a barren, frozen landscape on Enceladus. Instead, they witnessed colossal plumes of icy particles and water vapor erupting from geysers located near the South Pole. This revelation indicated the presence of a massive ocean concealed beneath its icy shell, sandwiched between the moon's rocky core and its frozen surface. The dynamic nature of this ocean, constantly expelling material into space, elevates Enceladus to a prime target for future exploration. And let's not forget Europa, one of Jupiter's moons, and arguably one of the most promising locations in our solar system to search for extraterrestrial life. Europa boasts a vast saltwater ocean, potentially reaching depths of 40 to 100 miles. Imagine, it could contain more water than all of Earth's oceans combined. However, a significant obstacle stands in our way: a thick ice shell estimated to be 10 to 20 miles thick, concealing the ocean beneath. Europa's ocean remains liquid due to the tidal forces exerted by Jupiter's immense gravity. The planet's colossal pull stretches and squeezes. Imagine a world far, far away, beyond our familiar Earth. Enceladus, a small moon, tirelessly orbits its parent planet. This constant dance with the massive planet generates tremendous gravitational forces, squeezing and stretching Enceladus. This perpetual squeezing action massages the moon's core, generating heat through friction, preventing its vast ocean from solidifying into ice. But the real thrill comes from the tantalizing possibility that scientists have observed water plumes erupting from cracks in Europa's icy shell, jets of ocean water spewing into the vacuum of space. If this holds true, we might be able to sample this alien ocean without undertaking the monumental task of drilling through miles of solid ice. Yet mysteries abound. What is the true size of Europa's hidden water reserves? How rapidly does this water refreeze under the intense cold? And how do the crushing pressures and frigid temperatures impact the ice itself? Scientists are driven to unravel these enigmas because Europa's ocean represents one of the most promising locations in our solar system to potentially discover extraterrestrial microbial life. Now, let's turn our gaze back to Earth, to the lush landscapes of the Oregon Cascades. Here, hidden beneath the surface, lies a colossal reservoir of water, dwarfing even the mighty Lake Mead in volume, holding more than twice the amount of water. To be precise, this hidden aquifer contains at least 19.4 cubic miles of water. To put that into perspective, it's equal to nearly 162 trillion individual water bottles. If you were to drink one bottle every single day, it would take you approximately 444 billion years to exhaust this supply. It's no surprise this underground aquifer discovery is so breathtaking. The Cascade Mountain Range, home to the largest aquifer on Earth, extends approximately 700 miles, stretching from northern California all the way into British Columbia. Within Oregon, the high Cascades are composed of younger volcanic rocks formed roughly 8 million years ago. In stark contrast, the Western Cascades are considerably older, dating back 45 million years, characterized by their deeply carved canyons and valleys. Scientists are meticulously studying the transition zone between these two distinct regions, seeking to understand how water has traversed through volcanic rock over vast stretches of time, and how volcanic processes have evolved across millennia. As part of this investigation, researchers measured the temperatures of the rocks at varying depths. This is when the astonishing discovery of the underground aquifer came to light. Normally, rocks at greater depths exhibit higher temperatures due to their proximity to the Earth's fiery interior. However, to everyone's astonishment, in certain areas, the temperature remained remarkably constant, even at extreme depths. This unexpected finding provided a crucial clue. Water was actively circulating through the rock, effectively cooling it down. In essence, the Cascades function as a natural water tower, diligently storing water and gradually releasing it into the rivers and streams that crisscross the landscape. These geological water findings hold profound significance for two primary reasons. First, they represent a potential water source for the future. Such a massive quantity of water, securely stored underground, could prove to be an invaluable resource. However, we currently lack a comprehensive understanding of how long it will remain in its current state and its ability to withstand future environmental changes. Therefore, further research is imperative to ensure its responsible management and use. Secondly, this vast water reservoir has a direct impact on volcanic activity. When water infiltrates deep underground and encounters magma, it instantly transforms into steam, generating immense pressure capable of triggering explosive volcanic eruptions. Understanding the amount of water stored within volcanic rock could be crucial in predicting future eruptions and assessing the associated risks. Despite the excitement surrounding this discovery, many questions remain unanswered. How exactly does this water navigate through the complex network of volcanic rock? And how much of it is actually suitable for use as a water resource? Given that this underground reservoir depends on rainfall and snowfall, prolonged periods of drought could pose significant challenges to both water supply and volcanic stability. Researchers are currently working diligently to fully understand the implications of the Cascades volcanic water reservoir and to develop strategies for its responsible management. But let's take a closer look at the geological marvel that is the Cascade Range. Imagine a colossal mountain range stretching from the northern reaches of California to the southern expanses of British Columbia. This range bisects the state of Oregon. Within Oregon alone, the Cascade Range spans approximately 260 miles in length and up to 90 miles in width, encompassing an area of 17,000 square miles. Even within the borders of the smallest U.S. states, colossal geological forces are at play. The Oregon portion of the Cascade Mountain Range is a testament to this, a landscape sculpted by ancient volcanoes, and incredibly, it holds vast reservoirs of volcanic rockwater storage deep beneath its surface. This majestic range owes its existence to a phenomenon known as the Cascadia subduction zone. Here, the Juan de Fuca tectonic plate, a substantial fragment of Earth's crust residing under the Pacific Ocean, is relentlessly being forced beneath the North American continent. As this immense plate descends into the depths, the crushing pressure and searing heat expel water from the oceanic rock. This expulsion lowers the melting point of the surrounding mantle, triggering the formation of magma. This molten rock, in turn, ascends to fuel the fiery volcanoes that define the Cascades. This entire process is but a segment of the Ring of Fire, the Earth's colossal belt of volcanic activity that encircles the Pacific Ocean like a fiery serpent. In essence, the Cascades are integral to a far grander volcanic system, a dynamic entity perpetually in flux. Remarkably, the Oregon Cascades comprise two distinct geological zones, the Western Cascades and the High Cascades, each possessing a unique character. The Western Cascades represent the range's ancient heart, born approximately 45 million years ago. These mountains are characterized by their rugged terrain, deeply etched by the relentless passage of rivers. Some of these canyons plunge to depths of up to 3,700 feet. This section of the range was once a hotbed of volcanic activity, but over eons, erosion has become the dominant sculptor, reshaping the land. The High Cascades, in stark contrast, are far younger and exhibit significantly less erosion. Around 8 million years ago, the epicenter of volcanic activity shifted eastward. Subsequent eruptions filled the ancient canyons, effectively smoothing the landscape. The rivers in this region simply haven't had the time to carve out the profound valleys that characterize the Western Cascades. Consequently, when juxtaposed, the two regions present a striking contrast. One appears jagged and deeply dissected, while the other boasts a smoother, more built-up appearance. Some of Oregon's most iconic volcanoes reside within the High Cascades. We're talking about the majestic Mount Hood, the imposing Mount Jefferson, the trio known as the Three Sisters, and the breathtaking Crater Lake, which owes its existence to the cataclysmic eruption and subsequent collapse of Mount Mazama. Unlike smaller, ephemeral volcanoes that emerge, erupt briefly, and vanish within months or years, these gargantuan volcanic centers have maintained their activity for millennia. This longevity results in far more complex magma systems beneath the surface. These systems yield a diverse array of volcanic rocks, ranging from basalt, a fluid, fast-flowing lava, to andesite, dacite, and rhyolite. Rhyolite, in particular, is the type of magma associated with colossal, explosive eruptions. Thus, while some of these volcanoes may merely ooze lava, others harbor the potential for devastating cataclysms. Another extraordinary characteristic of these long-lived volcanoes is the enduring heat within their underground magma chambers. This sustained heat makes the Cascades an ideal location for harnessing geothermal energy. A tremendous amount of heat lies dormant beneath the surface, awaiting utilization. And let's not overlook the Cascades' volcanic water reservoir, a resource with untold potential for future applications. As we've established, the Cascades form a segment of the magnificent Ring of Fire, the Earth's most volatile zone. Picture a vast horseshoe-shaped belt encompassing the Pacific Ocean, stretching an astonishing 25,000 miles. This is one of the most geologically dynamic regions on our planet. Here, Earth's tectonic plates engage in a constant dance of shifting, colliding, and grinding against one another, giving rise to some of the world's most formidable earthquakes, volcanic eruptions, and the formation of profound ocean trenches. The Ring of Fire traces the boundaries where numerous tectonic plates converge, all encircling the immense Pacific Plate. These plates are not static entities, They are perpetually in motion. Imagine the Earth's crust as a colossal jigsaw puzzle, with massive tectonic plates constantly jostling, grinding, and colliding against each other along fault lines. This immense, slow-motion struggle gives rise to some of the most dramatic geological features on our planet, from deep-sea trenches that plunge into the abyss to towering volcanoes that pierce the sky, and of course, violent earthquakes that can reshape the landscape in an instant. One of the most awe-inspiring examples of this titanic activity is the Mariana Trench, lurking in the western Pacific Ocean, east of Guam. Picture this, a chasm in the ocean floor, a staggering 7 miles deep. That's deeper than Mount Everest is tall. It's the deepest oceanic trench known to humankind, a place of crushing pressure and absolute darkness. This abyss was forged by a process known as subduction, where one tectonic plate is inexorably forced beneath another, sinking into the Earth's molten mantle. For a long time, it was believed that nothing could survive in such an extreme environment. The pressure alone is enough to turn any surface vessel into a tin can. Yet life, in its tenacious and adaptable forms, has found a way. In 2005, scientists made a remarkable discovery in the Challenger, deep, the very bottom of the Mariana Trench. Tiny single-celled organisms thriving in this seemingly impossible habitat. They also encountered bizarre, colorful rocky formations and strange, otherworldly sea cucumbers eking out an existence in the darkness. The Mariana Trench is also riddled with hydrothermal vents, underwater hot springs spewing superheated, acidic water into the surrounding ocean. It's a volcanic landscape from hell, yet even here, strange creatures and microscopic life forms have managed to adapt and thrive. The same tectonic forces that created the Mariana Trench are also responsible for the Ring of Fire, a vast horseshoe-shaped region encircling the Pacific Ocean. This zone is the epicenter of 90% of the world's earthquakes. Some of the most devastating seismic events in recorded history have struck here, including the 1960 Valdivia earthquake in Chile. This cataclysmic event registered a mind-boggling 9.5 on the Richter scale, the strongest earthquake ever recorded. But the Ring of Fire isn't just about earthquakes. It's also home to approximately 75% of the planet's volcanoes. Imagine the constant threat of eruption, the potential for unimaginable destruction lurking beneath the surface. Some of the most infamous volcanic eruptions in history have originated from this volatile region, such as the eruption of Mount Tambora in Indonesia. In short, the Ring of Fire is one of the most dangerous places on Earth, a testament to the immense power of geological forces. But it's also a place of incredible scientific interest. Who knows what other secrets and strange life forms might be discovered in this region? Perhaps something like the largest underwater reservoir discovered in the Cascades. Now, let's shift our focus to another danger in the Pacific, the ocean itself. In certain regions, ships are known to sink with alarming ease, a fact that has instilled fear in sailors for centuries. While numerous shipping routes crisscross this vast expanse of water, some are so treacherous that few dare to risk them, knowing that crossing them could mean facing the full fury of nature's power. Imagine needing to transport goods from Asia to America by ship. The most direct route would seem to be a straight line under the North Pacific Ocean. However, it might be wiser to avoid this path and opt for a longer, more expensive, but ultimately safer alternative. Why? Because the Pacific Ocean harbors some of the most dangerous waters on the planet. When we look at a world map, the Pacific often appears divided, masking its true size. In reality, this colossal body of water covers nearly a third of the Earth's surface. It's approximately 10 times larger than the Arctic Ocean, the smallest ocean in the world. This means that when traversing the Pacific, ships are often incredibly far from any potential landfall. In the event of an emergency, a mechanical failure, or a sudden storm, help could be days or even weeks away. This dramatically increases the risk of serious accidents, cargo loss, and even more dire consequences. Consider this. A ship journey from Santos, Brazil, to Cape Town, South Africa, covers just over 3,400 miles. But a voyage from Kela, Peru, to Shanghai, China, requires navigating approximately 10,000 miles of open ocean. Another significant hazard that deters sailors from crossing the Pacific is the presence of intense storm systems. Their very names, typhoons, hurricanes, cyclones, hint at the destructive forces they unleash. But the dangers don't end there. The Pacific is a realm of storms, often unpredictable and therefore exceptionally dangerous. Imagine sailing these waters, never knowing when the next tempest will erupt. Adding to the peril, near the equator lurks a constant threat: the trade winds. These powerful air currents exert a profound influence on the tropical climate, frequently unleashing torrential rains. Picture these winds as relentless whirlwinds, ceaselessly spinning across the ocean's surface. These trade winds, while vital for distributing moisture across vast forests and shaping even the formation of deserts, present a significant hazard. Their intensity is far from constant, fluctuating dramatically with the changing seasons. In winter, for instance, they can surge to terrifying levels. And because these winds dictate the movement of ocean waters, they generate fierce sea currents, transforming any voyage into a potentially deadly gamble. In 2015, a research team encountered a series of unusually potent winter trade winds. The result was a barrage of short, sharp waves that hammered the Pacific. Picture their vessel being relentlessly pounded, each wave a crushing blow. The ship's hull groaned and twisted under the assault, its structure warped and deformed. The scientists confirmed what seasoned sailors already knew. Winter trade winds are a force to be reckoned with, a genuine threat to any vessel daring to cross their path. And let's not forget, in the vast emptiness of the Pacific, help can be agonizingly slow to arrive. So, we realize there are multiple reasons to fear these winds. The sheer scale of the Pacific Ocean, largely devoid of geographical barriers like mountains or large islands, amplifies their power. With no landmasses to impede their progress, the trade winds and ocean currents are free to gather immense strength and speed. This explains why the Pacific is notorious for its colossal storms and towering waves. Contrast this with the North Atlantic, where the land masses of North America, Europe, and Africa serve to contain and redirect atmospheric and maritime systems, mitigating their intensity. Scientists often describe the Pacific Ocean floor as a gigantic jigsaw puzzle, a chaotic collection of shifting pieces. It's home to the planet's greatest concentration of tectonic plates, including the colossal Pacific Plate, the largest oceanic plate ever identified. This geological instability makes the region exceptionally prone to earthquakes and volcanic eruptions. Even when the ocean's surface appears deceptively calm, its underlying geology means that conditions can change with frightening speed. This inherent unpredictability makes the Pacific a truly treacherous environment. Take, for example, the unfortunate case of the cargo ship One Apis in 2022. While traversing the ocean roughly 1,600 nautical miles northwest of Hawaii, it was engulfed by a ferocious storm. The consequences were devastating. Over 1,800 containers were lost to the depths, while hundreds more collapsed on deck, transforming into a cascade of steel dominoes under the relentless force of the wind. The captain, displaying remarkable skill, managed to steer the crippled vessel towards Japan, a journey that took nearly a week. Only upon reaching port did the full extent of the damage become clear. And the One Apis was not alone. The following year, the MK Essen lost approximately 750 containers, while the MK Eindhoven shed over 260. All three ships were bound for Asia. These incidents alone far exceeded the average annual global loss of containers at sea, which stands at roughly 1,382. What's particularly striking is that all these events occurred during winter. Speaking of winter, it was in the winter of 2020 that the Pacific etched its name in the record books. Scientists documented a wave reaching a staggering 58 feet in height, equivalent to a 5 or even 6-story building. Imagine the raw, untamed power of the ocean, a force capable of dwarfing even the most impressive structures. Consider a standard wave. Now picture one towering above it, not just a little, but nearly 3 times its height. These are rogue waves, unpredictable behemoths of the sea. While terrifying and rare, it's crucial to understand that these giants, born of wind and weather, are not tsunamis. A true tsunami is usually the aftermath of colossal geological events, underwater earthquakes, or cataclysmic volcanic eruptions that violently displace the ocean floor. But the Pacific's fury doesn't end there. Enter the realm of typhoons, monstrous storms that churn across the ocean's surface. The typhoon season of 2024 served as a stark reminder of their power. Take Hurricane Christy, a swirling vortex of destruction. Though it thankfully remained at sea, sparing land from direct impact, its potential for devastation was immense. Christy reached Category 5 on the Saffir-Simpson scale, the absolute pinnacle of hurricane intensity. A storm of this magnitude is deemed catastrophic. It unleashed colossal waves and treacherous rip currents. And then there was Super Typhoon Yagi. This storm slammed into the Asian continent with such ferocity that it earned a reputation as the most potent typhoon in the last 70 years. When Yagi finally made landfall in Vietnam, the devastation was staggering. The storm left behind a trail of destruction, inflicting damage estimated at around 1.6 billion, obliterating infrastructure across numerous cities, and claiming countless victims. As if these threats weren't enough, the Pacific Ocean also cradles the infamous Pacific Ring of Fire, one of the most unstable regions on our planet. Picture a colossal, crack-shaped zone, a hotbed of intense volcanic and seismic activity. It is the most tectonically active place anywhere in the world. Here, the Earth's tectonic plates are in constant motion, grinding against each other, colliding head-on, or sliding apart. This relentless activity triggers frequent earthquakes and volcanic eruptions. Seismographs in the region detect some form of tremor, on average, every 5 minutes. This perilous zone accounts for a staggering 90% of the planet's earthquakes. 9 out of every 10 tremors originate from within this ring, which encircles much of the northern Pacific. The reach of this volatile region extends far beyond North America and Asia. In 2023, tremors linked to the Ring of Fire reverberated across several Latin American nations, including Argentina, Chile, Ecuador, and Peru. The result was a swath of destruction and the tragic loss of approximately 15 lives. Given these myriad dangers, it's no surprise that ships often choose longer, safer routes across the Pacific, avoiding the shortest paths. After all, as the old adage goes, prevention is far better than cure. Now, imagine yourself descending into the inky blackness of the ocean depths in a submarine. Anxiety gnaws at you as you prepare to explore the ocean floor, hundreds of feet below the surface. So many things could go wrong. Technical malfunctions, the crushing pressure of the water, encounters with monstrous marine creatures, and then there are the mysterious, unsettling sounds. What was that? Strange, eerie sounds echoing from the abyss. A bizarre humming noise emanating from the deep. What makes it even more unsettling is that it only appears during the twilight hours of dusk and dawn. Some speculate that this eerie hum might act as a dinner bell, somehow linked to the vertical migrations of massive groups of marine creatures as they move up and down through the water column to feed. For now, it remains a mystery. Using extremely sensitive underwater microphones, researchers have managed to record this mysterious, low-frequency hum at depths ranging from 660 to 3,300 feet. The sound itself is quite faint, barely registering 3 to 6 decibels above the normal background noise of the ocean. To put that into perspective, a whisper in a quiet library measures around 30 decibels. The underwater noise also possesses an odd, humming quality. Despite their best efforts, the source of the mysterious sound remained elusive, with researchers unable to attribute it definitively to any single marine species. The sound seems to emanate from a region of the ocean known as the Twilight Zone. Imagine this realm. A dark, nutrient-poor environment where sunlight fails to penetrate, making photosynthesis impossible. Life in this zone depends entirely on the organic detritus that drifts down from the sunlit layers above. The decaying remains of organisms and discarded organic matter. But don't let the description fool you into thinking it's a lifeless void. The Twilight Zone is teeming with life. A groundbreaking study in 2015 suggested that this zone could be home to as much as 90% of the world's fish population, including countless species yet to be discovered. So, what about this strange, haunting noise? Researchers are focusing on the daily vertical migration of small marine creatures, fish, shrimp, and squid, as a potential source. These animals undertake a massive journey, rising towards the surface at sunset to feast on plankton and nutrients under the cover of darkness, a strategy to evade predators. Then, as the first rays of dawn appear, they retreat back to the safety of the depths. This incredible migration, one of the most significant animal movements on our planet, involves billions upon billions of creatures every single day. The prevailing theory is that the mysterious hum may be a form of communication, a way for these creatures to coordinate their movements during this massive daily migration. Perhaps it's a signal indicating that it's safe for the group to ascend to the surface and begin feeding. If this is the case, deciphering this hum could unlock invaluable insights into the complex lives of deep-sea organisms. The Twilight Zone, once thought to be a silent world, may in fact be buzzing with intricate social behaviors and interactions we are only beginning to understand. But the ocean isn't the only source of mysterious sounds. Our entire planet is humming, constantly, relentlessly. Sadly, this deep, resonant hum is beyond the range of human hearing. It's not caused by earthquakes, but by subtle, continuous vibrations within the Earth's crust. These vibrations are so faint that we can't feel them, detectable only with highly specialized equipment. Scientists have been aware of this phenomenon, known as free oscillation, for quite some time and have diligently recorded this persistent hum. Earthquakes, of course, are the most dramatic and noticeable ground movements. According to the United States Geological Survey, our planet experiences around 500,000 earthquakes each year. Of these, only about 100,000 pulses are strong enough to be felt, and a mere 100 cause significant damage. But even between these dramatic seismic events, the Earth is constantly vibrating with subtle, imperceptible movements. Unlike the sudden, violent jolts of earthquakes, this hum is a steady, uniform background vibration, a byproduct of microseismic activity. Seismometers, instruments designed to detect and record ground vibrations, can pick up this hum anywhere on land. For years, the origin of this mysterious hum has been a subject of intense debate among researchers. Some initially proposed that it originated from ocean waves exerting pressure deep on the seafloor. Others theorized that it was caused by the collision of waves on the ocean's surface. By 2015, scientists had reached a consensus. Both of these factors contribute to the Earth's continuous vibration. And while this hum has been recorded on land for decades, we are now obtaining much clearer, more detailed recordings from instruments placed deep beneath the ocean surface. To study this elusive hum, researchers deploy spherical seismometers on the seafloor in the Indian Ocean, near an island just east of Madagascar. Imagine this: between September 2012 and November 2013, 57 free-fall seismometers were strategically placed across a 772 square mile area. These sophisticated devices are engineered to sink to the ocean floor and record even the faintest vibrations. Over the course of this intensive 11-month study, the team meticulously filtered out extraneous noise from ocean waves and seafloor currents. What remained were clear, consistent signals of Earth's hum, with peak frequencies between 2.9 and 4.5 millihertz, far below the threshold of human hearing, which begins at approximately 20 hertz. The discovery of Earth's hum. Delving into the mysteries hidden beneath the ocean's surface offers more than just scientific curiosity. It unlocks a new understanding of how energy courses through our planet's crust and the very mantle itself. The world around us constantly hums with strange sounds, many of which defy explanation. Consider the bloop, an ultra-low frequency, high-amplitude underwater sound detected in 1997 by the U.S. National Oceanic and Atmospheric Administration, NOAA. Imagine this sound. It persisted for over a minute, beginning as a deep, resonating rumble that gradually intensified in frequency. The sheer power of this sound was so immense that hydrophones, those underwater microphones, picked it up across a staggering distance of 3,000 miles. Initially, speculation ran wild. Some experts wondered if it could be the call of an undiscovered colossal sea creature, something lurking in the deepest trenches. However, further analysis led NOAA scientists to a more plausible explanation: the fracturing of icebergs. Picture colossal pieces of Antarctic glaciers calving, breaking away, and violently crashing into the sea. The immense forces involved could generate such a powerful sound. Another enigma is the sound known as Julia, a bizarre, almost burping noise. It's theorized that an iceberg scraping along the ocean floor could produce such an oddity. Then there's the sound dubbed train, so named because of its eerie similarity to the screech of train wheels grinding on a track. This one likely originates from the Ross Sea, near Antarctica. And let's not forget upsweep, a recurring seasonal scratchy noise that has baffled researchers in the Pacific Ocean since 1991. Despite years of investigation, its precise origin remains shrouded in mystery. But the underwater world offers more than just unexplained noises. It also features bizarre sounds that can best be described as the choirs of fish. Picture this: scientists studying marine life off the coast of Port Hedland in Western Australia made a fascinating discovery. Many fish species engage in synchronized choruses at both dawn and dusk, much like our familiar birdsong. Over a period of 18 months, researchers recorded a cacophony of sounds, including foghorn-like calls from black jewelfish and rhythmic ba-ba sounds from batfish. These complex fish songs, often involving repetitive calls overlapping from large groups, play a crucial role in their breeding rituals, feeding habits, and territorial displays. Venturing deeper still, NOAA researchers even explored the soundscape of the Challenger Deep, the absolute nadir of the Mariana Trench. To accomplish this, they deployed a specially designed, titanium-encased hydrophone capable of withstanding the immense pressure at that depth, over 1,000 times the atmospheric pressure we experience at sea level. Over a span of 23 days, this remarkable device captured a wealth of sounds, from the haunting melodies of whales echoing through the abyss to the low rumble of distant earthquakes reverberating through the earth. So, we've established that the ocean is alive with strange and wonderful sounds. But the weirdness isn't confined to the depths. Even above ground, unusual noises abound. One of the most perplexing is simply known as the hum, a low-frequency drone reported by people in specific locations such as Taos, New Mexico, or Bristol, England. This sound is often described as a faint engine-like hum, and its source remains stubbornly elusive. Some researchers speculate that it might be a psychological phenomenon, where individuals focus on subtle background noises that they would ordinarily filter out. Whatever the explanation, no definitive answer has yet emerged. Even geological formations can sing. Consider Utah's Rainbow Bridge, a colossal 300-foot-high sandstone arch. This natural wonder vibrates like a guitar string when exposed to ambient sounds, distant seismic activity, or even the lapping of waves near Lake Powell. Scientists have meticulously studied its resonant frequencies to better understand how these vibrations might impact the bridge's long-term stability. Interestingly, visitors to Rainbow Bridge have also reported hearing faint humming sounds emanating from the rock itself. And the skies have their own eerie symphony. For centuries, people living in the polar regions have described faint sizzling, popping, and crackling sounds accompanying the mesmerizing displays of the aurora borealis, or northern lights. A Finnish researcher made the first known recordings of these elusive sounds, tracing their origin to electrical discharges occurring in the lower atmosphere, approximately 230 feet above the ground. Imagine standing on the shores of the prehistoric ocean millions of years ago. Even the earth itself seemed to whisper secrets. But these were not the gentle lapping of waves, but deeper, stranger sounds emanating from the very core of the planet. Magnetic storms, those invisible tempests fueling the mesmerizing auroras, hummed with subtle, almost inaudible tones on still, clear nights. Further out to sea, colossal icebergs groaned and screeched as they ground against the seafloor. Beneath the waves, volcanic activity rumbled like the belly of some immense, sleeping beast. Scientists, in our time, listen to these sounds, deciphering the movements of glaciers and the hidden geology of the ocean depths. But let's journey back 66 million years. Picture the scene. It could have been a Tuesday in September for all we know. Without warning, a monstrous asteroid, a harbinger of cosmic chaos, hurtles toward Earth. The impact is catastrophic, a world-shattering event that would forever alter the course of life. The dinosaurs, those magnificent rulers of the planet, face their final moments. We're talking, of course, about the infamous Chicxulub impactor, the asteroid that carved a massive scar into the Yucatan Peninsula in Mexico and ushered in a new age. But what if I told you that Chicxulub wasn't a solo act? Recent findings have confirmed that another, smaller but still devastating asteroid struck Earth around the same time. This second space rock slammed into the Atlantic Ocean off the coast of West Africa. It carved out a submerged crater, now known as the Nadir crater. And believe me, this was no gentle splash. The force of the impact unleashed a colossal tsunami, a wall of water estimated to be over 2,600 feet high, nearly as tall as the Burj Khalifa, the very symbol of modern engineering. How did scientists arrive at this earth-shattering conclusion? A researcher, Dr. Nicholson, stumbled upon the Nadir crater in 2022 while examining high-tech scans of the ocean floor. There, beneath nearly 1,000 feet of water, lay a massive depression, a gaping wound in the Earth's crust spanning over 5.5 miles. Initially, it was just a possibility, a tantalizing hint of another impact. But now, the evidence is undeniable. A second asteroid joined the Chicxulub impactor in hammering Earth during the twilight of the dinosaurs. The key to unlocking this ancient secret lies in super high-resolution 3D seismic images. These advanced scans allowed researchers to peel back the layers of sediment on the ocean floor, revealing the crater in stunning clarity. It was like upgrading from a blurry old photograph to a crystal-clear 3D rendering, every detail brought into sharp focus. These findings confirm that the Nadir crater was gouged out by an asteroid somewhere between 100 and 1,640 feet wide. The impact was cataclysmic. It didn't just punch a hole in the seabed, it unleashed a cascade of geological mayhem. The sheer force of the collision created a central peak within the crater, a towering monument to destruction. Concentric ridges rippled outwards from the point of impact, and a zone of intense damage spread for thousands of miles. With those incredibly detailed images, scientists have painstakingly reconstructed the events that unfolded in the immediate aftermath of the impact. The asteroid plunged into the ocean, creating an initial bowl-shaped cavity. The shock wave ripped through the water and the seabed, triggering massive underwater landslides. The soft sediments surrounding the crater collapsed inwards, forming a distinct rim around the newly formed abyss. And then, of course, came the tsunami. But this wasn't just a single, monstrous wave. The models suggest a series of colossal waves, a relentless train of tsunamis surging outwards, then, incredibly, reflecting back towards the crater. These returning waves left their own scars on the ocean floor, further attesting to the immense power unleashed that day. The discovery of the Nadir crater is a monumental achievement for paleontology and planetary science. It provides a rare opportunity to study a marine impact crater in exquisite detail. Only around 20 such craters have been confirmed across the globe, and none have been captured. This new data offers paleontologists an unprecedented level of accuracy. Imagine the possibilities. Scientists can now rigorously test their theories about how impact craters form beneath the waves. Unlike their terrestrial counterparts, these marine craters have remained stubbornly hidden, concealed under millennia of accumulated sediment, making detailed study a real challenge. But now, with this groundbreaking 3D imaging technology, we can peel back the layers, examining the crater's structure in remarkable detail. It's akin to carefully slicing into a complex cake, revealing its hidden textures and layers. Dr. Nicholson and his team are already envisioning the next step, drilling deep into the heart of the crater and extracting samples from the rock far below the ocean floor. Imagine the insights these samples could provide. They could precisely measure the immense shock pressures generated during that cataclysmic impact and piece together the sequence of events that unfolded in the minutes, hours, and days following the collision. Of course, when we speak of dinosaur extinction, the infamous Chicxulub impactor remains the undisputed heavyweight champion. This colossal space rock, estimated to be between 6 and 9 miles in diameter, truly immense, struck the Earth at a particularly devastating angle. The impact instantly vaporized rock, and colossal plumes of gas were ejected high into the atmosphere, triggering a catastrophic impact winter that may have lasted for as long as 15 long years. This obscuring cloud blocked out vital sunlight, plunging the Earth into prolonged darkness and initiating a cascade of ecological disasters. Now here's a fascinating theory. Some experts propose that the smaller, more recently discovered Nadir crater might actually be a fragment, a chunk that sheared off the main Chicxulub asteroid just before its fateful collision with Earth. This is still speculative, but if proven true, it would paint an even more dramatic picture. Earth enduring a terrifying double impact from space. Let's journey back in time now, to the remote Siberian wilderness of 1908. Picture the scene: endless forests, winding rivers, and then, without warning, a massive object, perhaps 150 to 300 feet across, streaks through the atmosphere with unimaginable speed. Was it a comet? An asteroid? The precise nature of this celestial intruder remains a mystery to this day. What is certain, however, is that this object detonated high above the Tunguska River, unleashing one of the most powerful explosions in recorded human history. The force of the blast was simply staggering, flattening the surrounding forest for miles in every direction. 80 million trees were instantly incinerated or uprooted across an area of approximately 830 square miles, a zone larger than sprawling modern cities like Los Angeles or New York. The surviving trees were flattened, their branches sheared off, and arranged in an eerie radial pattern emanating outwards from the blast's epicenter. Consider the unimaginable consequences if this event had occurred above a major population center. Every structure would have been reduced to rubble, and the loss of life would have been incalculable. Fortunately, the Tunguska event occurred in one of the most sparsely populated regions on Earth. Yet, perhaps the most unsettling aspect of the Tunguska event is that when scientists finally reached the remote site years later, they found no impact crater. This only deepened the mystery. The prevailing explanation is that the object exploded in the atmosphere, likely between 3 and 6 miles above the ground, preventing it from actually striking the surface. However, this aerial detonation did nothing to diminish the destructive power of the blast. Now, let's leap forward to 2013, when the skies above Chelyabinsk, a city in Russia, were shattered by another extraordinary event. On a seemingly ordinary February morning, an asteroid, estimated to be around 60 feet in diameter, blazed into Earth's atmosphere, creating a dazzling spectacle across the sky. It was traveling at a mind-boggling speed of approximately 43,000 miles per hour. The asteroid exploded in midair, about 18 miles above the city. While the view was awe-inspiring, the situation was fraught with peril. Fortunately, the asteroid disintegrated at a sufficient altitude that no fragments reached the ground. Had it struck the surface directly, Chelyabinsk would have faced a catastrophe of immense proportions. However, even without a direct impact, the atmospheric explosion generated a powerful shockwave that ripped across the landscape with tremendous force, shattering windows and inflicting damage on buildings throughout the city. The blast wave damaged approximately 7,200 buildings. Miraculously, there were no direct fatalities. Nevertheless, the Chelyabinsk event served as a starker reminder that Earth remains vulnerable to cosmic impacts. It was a major wake-up call, demonstrating that these events are not just the stuff of ancient history. Imagine a cosmic gunshot, an asteroid, a celestial bullet, explodes high above a populated area. The damage is real, a stark reminder of our vulnerability. But there's good news on the horizon. Our ability to detect these cosmic wanderers is improving. Space agencies like NASA are diligently tracking near-Earth objects, meticulously calculating trajectories, and identifying potential threats. Yet, as history has shown, space rocks can still take us by surprise. The odds of a major impact remain low, but the potential consequences are astronomical. Right now, NASA has a particular space rock under close observation. Its name is Bennu, and it's roughly the size of that Tunguska impactor, a chilling reminder of destructive potential. Bennu is classified as one of the most hazardous objects lurking in near-Earth orbit. NASA calculations suggest a small probability of a collision with Earth between the years 2158 and 2290. The date of greatest concern, September 24th, 2182. But hold your breath. The odds of an impact are slim, just 1 in 2700. Still, this serves as a stark reminder. Our planet is perpetually in the cosmic crosshairs. Now picture this. The snowpack above you cracks, splitting apart right before your eyes. Massive chunks begin to tumble down the frozen slope, rushing towards their final resting place far below. Anything caught in its path is pulverized under the immense weight of snow and ice. You are witnessing an avalanche, one of nature's most formidable and dangerous displays of raw power. But what if I told you there exists another type of avalanche, equally terrifying, yet occurring in a realm we rarely consider? An underwater avalanche. And what's even more bizarre is that these events happen constantly, hidden beneath the ocean's surface. Underwater avalanches are incredibly powerful and potentially disastrous natural phenomena, often dwarfing their terrestrial counterparts in both scale and destructive force. They possess the capability to unleash havoc on a global scale, leading to catastrophic consequences. The truly alarming aspect? They are constantly unfolding beneath the waves, invisible to the naked eye, virtually impossible to predict, and exceedingly difficult to measure. These underwater behemoths can be hundreds of times larger than avalanches on land, posing a significant threat to global communications. Imagine the entire planet plunged into an internet blackout. But we'll delve into that later. First, let's journey back 60,000 years. Our destination, the northwest coast of Africa. We are about to witness the colossal magnitude and devastating impact of a gargantuan underwater avalanche. It began as a relatively small underwater landslide within the Agadir Canyon. Initially, it involved a mere 0.35 cubic miles of material. However, almost instantaneously, this mass swelled to over 100 times its original size as it surged across the Atlantic Ocean floor. As the avalanche gathered momentum and expanded, it incorporated gravel, sand, rocks, and mud, carving a path of destruction through one of the planet's largest submarine canyons. Imagine the scene. All forms of marine life, both animal and plant, obliterated in its wake. The catastrophic flow was so potent that it literally eroded a 250-mile stretch of the canyon, gouging hundreds of feet into its sides and impacting a total area of 1,740 square miles, an area equivalent to more than 3.5 New York cities. The force of this underwater torrent was so immense that it propelled massive boulders up the canyon walls to astonishing heights of up to 430 feet. Before scientists unearthed the evidence of this cataclysmic event, they significantly underestimated the sheer destructive potential of submarine avalanches. And here's another chilling thought. These devastating catastrophes can originate not only in the deep ocean, but also in seemingly innocuous estuaries. Let's rewind to January 14th, 2020, and witness this firsthand. A turbidity current, a rapid downhill surge of water laden with sediment, rushed. Imagine a hidden world, deep beneath the ocean waves. Far from the familiar shores, more than 680 miles from the Congo River estuary, lies a realm of immense power and unseen forces. Here, in the crushing depths, a remarkable event unfolded. In late December 2019, a cataclysm began. Unprecedented flooding along the Congo River, coupled with unusually large spring tides, triggered a phenomenon of staggering proportions. It was an avalanche, but not of snow. This was an avalanche of sand and mud, a subterranean landslide of epic scale. Consider the volume. This single avalanche contained a third of all the sediment produced annually by every river on Earth combined. A monstrous slurry of earth and debris unleashed into the Congo Canyon. This wasn't a gentle slide. It was an accelerating surge. The avalanche picked up speed, racing down the canyon. Initially, it moved at 17 feet per second, but as it plunged towards the ocean depths, it reached a terrifying 26 feet per second. This colossal flow continued for almost 700 miles from the coastline, earning its place as the longest sediment avalanche ever recorded. 2 days later, the unthinkable occurred. The avalanche reached the deep ocean, its destructive power impacting even our modern world. It severed two vital seabed telecommunication cables, disrupting internet data speeds across West, Central, and South Africa. A stark reminder that even the deepest ocean holds forces capable of affecting our interconnected lives. Before this event, scientists considered the measurement of such powerful deep-sea avalanches nearly impossible. Yet the Congo Canyon sediment flow provided a unique opportunity for direct monitoring. Researchers could finally assess the connection between major river floods and the deep sea. The frequency of underwater avalanches, they discovered, is heavily dependent on location. Canyons near river mouths might experience several smaller avalanches each year. In contrast, systems far from river discharges like the Agadir Canyon might only see a truly monstrous avalanche once every 10,000 years. What, you might ask, are the triggers of these submarine behemoths? Earthquakes, typhoons, extreme tides, river floods, even volcanic eruptions can all set these events in motion. And, worryingly, our changing climate is making such triggers more frequent and intense. However, the presence of a trigger doesn't guarantee an avalanche, nor does it dictate its scale. Consider the Great Lisbon Earthquake of 1755. This devastating event, which decimated Lisbon and claimed tens of thousands of lives, only triggered a small underwater avalanche. Then, in 1929, a major earthquake off the coast of Newfoundland, Canada, unleashed the largest underwater avalanche ever recorded. This colossal flow, traveling at a staggering 42 miles per hour, carried boulders, sand, and mud with terrifying force. It snapped 11 seabed cables in its path and generated a tsunami that claimed the lives of 28 people along the coastline. The power of the deep is not to be underestimated. These submarine avalanches occur far from view, making them incredibly difficult to study. Yet understanding them is crucial. They play a vital role in transporting sediments, nutrients, and even pollutants across the ocean floor, shaping the very landscape of the deep. Driven by this need to understand, a research team from Liverpool embarked on a mission to unravel the mysteries of these underwater events. Over the past 40 years, they have painstakingly collected more than 300 samples from the ocean floor. Combining this with seismic and bathymetric data, essentially ocean mapping, they managed to reconstruct a massive submarine avalanche. It was a breakthrough, the first time an underwater avalanche of this size had ever been mapped. The event, remarkably, began modestly, but quickly escalated into a colossal avalanche, reaching heights of over 650 feet. To grasp the scale, imagine an avalanche the size of a skyscraper surging from Liverpool to London, carving a trench 100 feet deep and 9 miles wide. Then imagine it spreading out over an area larger than the UK, burying the entire region under several feet of sand and mud. That's akin to burying a whole. These discoveries carry significant weight, revealing that even a seemingly minor underwater landslide can escalate into a colossal and devastating event. But the potential for destruction doesn't end there. Consider the vast network of undersea internet cables, the very arteries of global communication. Across the ocean floors of the world, there are over 550 active seafloor cables. Their combined length stretches to an astonishing 870,000 meters, enough to encircle the Earth a staggering 35 times. When a submarine avalanche strikes and severs these vital cables, the consequences are typically catastrophic and incredibly costly. A stark example occurred in 2006 when an earthquake near Taiwan unleashed a series of underwater avalanches, severing numerous seafloor cables that connected Southeast Asia to the wider world. The largest internet provider in China experienced a staggering 90% drop in traffic to the United States at the peak of the crisis. Taiwan itself suffered an internet outage ranging from 74% to a complete 100% loss of connectivity to neighboring islands. It becomes clear why unraveling the mysteries of this natural phenomenon is so crucial. Fortunately, researchers at Toan University have pioneered a method to study these events in 3 dimensions. Earlier investigations were limited to 2-dimensional analyses, failing to capture the full complexity of their behavior. This groundbreaking research focuses on how underwater flows interact with mini basins, natural formations on the ocean floor resembling shallow bowls. Despite the mini designation, these basins can be immense, spanning up to 4 square miles. When powerful turbidity currents surge into these mini basins, they don't simply come to a halt. Instead, they collide with the far side and swirl back, mirroring the eddies in a rushing stream. These swirling flows redistribute sediment before it settles onto the ocean floor. The size of the mini basin and the velocity of the flow exert a profound influence on the current's behavior. In a large basin with a sluggish current, sediment gradually accumulates. However, if the flow intensifies or the basin shrinks, the current overflows, spilling over the basin's rim. To meticulously examine these dynamics, the researchers constructed a scaled-down replica of a mini basin in a controlled pool environment. They then simulated turbidity currents using varying flow speeds. They even engineered their own sediment mixtures to observe how particles of different sizes behaved under these conditions. Ultimately, they succeeded in replicating real-world ocean conditions on a smaller, more manageable scale. Ingenious, isn't it? Now, imagine a scenario where all the volcanoes on Earth erupted simultaneously. The noise alone would be deafening. We'd witness approximately 500 flowers of these geological powerhouses erupting at once. Under normal circumstances, only about 10 to 20 volcanoes exhibit activity each day. But what would be the global impact if they all blew their tops in unison? Geologists anticipate a grim outcome. Even if only the land-based volcanoes erupted together, it would trigger a chain reaction far exceeding anything in recorded history. The primary threats would be ash and volcanic gases, while the initial explosions and lava flows would inflict damage on nearby populations. The true peril lies in the aftermath. A dense blanket of ash would envelop the planet, plunging it into darkness. The absence of sunlight would halt photosynthesis, decimating crops, and causing a dramatic drop in temperatures. This persistent ash cloud could linger in the atmosphere for as long as a decade. And beyond the ash, there's the looming threat of acid rain. Volcanic gases, such as hydrochloric acid and sulfur dioxide, would mingle with the atmosphere and return to the surface as corrosive acid rain. This corrosive precipitation would contaminate groundwater and acidify ocean surfaces. Even if humanity managed to survive the initial cataclysm, coral reefs would vanish and the delicate balance of marine ecosystems would be shattered. But imagine the impact: a world choked by ash, the sun obscured, acid rain lashing the land, and the oceans turning into a toxic soup, devoid of the life they once supported. Even creatures far removed from the immediate volcanic fallout would suffer. Scientists have observed echoes of such catastrophic events on a smaller scale throughout Earth's long history. Major volcanic eruptions have been implicated in several mass extinction events. Consider Mount Pinatubo's eruption in 1991. It cooled global temperatures for a full 2 years. But the massive amounts of carbon dioxide released by such eruptions could also trigger a runaway greenhouse effect, broiling the planet like an unattended casserole under a grill. Geological records hint that similar events may have unfolded in the distant past. During the Cretaceous period, for instance, carbon dioxide levels were astronomically higher than they are today, creating a hostile environment for marine life. So, who could possibly survive such a global cataclysm? Perhaps only extremophiles. Those remarkable organisms that thrive in the most punishing conditions imaginable, like the scalding heat of hot springs or the crushing pressure and toxic chemicals spewing from deep-sea hydrothermal vents. As for humanity, we could theoretically huddle in underground bunkers, waiting for the storm to pass, or construct massive space stations capable of housing the entire human population. But let's be honest, that's a far-fetched dream. Thankfully, the odds of every volcano on Earth erupting simultaneously are incredibly low. Why? Because there isn't a single, unified magma source feeding them all. Each volcanic vent typically draws from its own isolated reservoir of molten rock, with only a few exceptions where volcanoes share a common magma chamber. For example, in 1912, Novarupta in Alaska erupted in tandem with another volcano that shared its magma supply. Scientists have also detected evidence of magma lurking beneath seemingly dormant volcanic zones, such as the Taupo volcanic zone in New Zealand. This magma can spread horizontally over considerable distances, but it remains a localized phenomenon. Even if we were to consider all the magma beneath Taupo as a single interconnected system, it's still isolated from other volcanic regions like those in Indonesia or the Philippines. Because the vast majority of volcanoes are independent entities, they can't be synchronized to erupt in unison. Their magma originates from various processes, such as mantle decompression or the introduction of water into the mantle through subduction. The very nature of plate tectonics makes a simultaneous global eruption virtually impossible. However, this doesn't mean we won't witness fascinating volcanic activity in the future. Consider the underwater region near British Columbia, where scientists have recently recorded roughly 200 minor earthquakes every hour. Deep beneath the Pacific Ocean floor, off the coast of Vancouver Island, magma is poised to erupt, superheating the surrounding water until it boils like a shaken soda bottle. But this event will likely be imperceptible to anyone but the scientists monitoring it. The expected eruption will occur approximately 3 miles beneath the ocean's surface. Experts explain that the earthquakes range from negative to 4.1 in magnitude, meaning only those in close proximity would feel even the slightest tremor. This unusual activity presents a unique opportunity to study the formation of Earth's crust. The magma beneath the ocean floor is estimated to be nearly 1,500 degrees, 815 degrees, but it will cool rapidly upon contact with the frigid water. This molten rock will quickly solidify on the seafloor, transforming into a dark, glassy rock. Biologists will also benefit, gaining insights into how marine life responds to the sudden changes caused by the eruption. Even Antarctica, seemingly a desolate, frozen wasteland, harbors a volcanic secret beneath its icy shell. Researchers have identified over 130 volcanoes beneath the West Antarctic ice sheet alone, making it potentially the largest volcanic region on Earth. Most of these volcanoes, around 90, were only discovered recently, in 2017. But could any of these Antarctic volcanoes actually erupt? The answer depends on which specific volcano we're talking about. While these geological formations are relatively young, geologically speaking, it's challenging for scientists to determine definitively whether they are still active. Only 2. Across the icy expanse of Antarctica, the Earth still breathes fire. 2 volcanoes stand as confirmed active giants: Deception Island and the imposing Mount Erebus. The latter, a colossal peak dominating the frozen landscape, has been in a state of near-constant eruption since at least 1972. Imagine a mountain that perpetually coughs plumes of gas and steam, occasionally hurling rocks in what volcanologists call strombolian eruptions. But the most extraordinary feature of Mount Erebus is the persistent lava lake simmering within its crater. This is a rare phenomenon, a testament to the unique geological conditions at play. Deep within the Earth's mantle, a steady supply of magma fuels this molten lake. This continuous inflow of superheated rock provides the very material for the lava lake's existence. And despite its Antarctic location, the summit of Erebus experiences relatively mild temperatures due to the intense geothermal heat. This prevents the lava lake from solidifying, allowing it to remain in its liquid, fiery state. Deception Island, another of Antarctica's active volcanoes, last erupted in the 1970s. While currently quiet, it remains under close scrutiny, constantly monitored for any signs of renewed activity. But these 2 are not alone. Across Antarctica, fumaroles, openings in the Earth's crust, release gases and vapors, sometimes forming icy towers that can reach up to 10 feet in height. Yet it is the supervolcanoes that truly capture our attention. These are the geological titans capable of unleashing the most massive and destructive eruptions imaginable. Unlike typical volcanoes with a single vent, supervolcanoes possess vast magma chambers beneath the surface, stretching for tens, even hundreds of miles in diameter. Imagine the scale of such a reservoir of molten rock. Their eruptions can trigger catastrophic consequences, not just locally but globally, impacting climate patterns due to the sheer volume of ash and gases ejected into the atmosphere. One of the most famous, or perhaps infamous, supervolcanoes is Yellowstone, located in the United States. Some experts believe it is building towards another eruption. Yellowstone has the potential to unleash a colossal explosion, spewing over 240 cubic miles of debris into the atmosphere. But volcanoes, as powerful as they are, do not adhere to human schedules. Eruptions occur when sufficient magma accumulates beneath the surface and when the pressure is high enough to force that magma upwards. Current measurements suggest that these conditions are not presently met at Yellowstone. While many volcanoes operate on cyclical patterns, this doesn't necessarily mean Yellowstone is overdue. In fact, over the past 2.1 million years, Yellowstone has experienced only 3 major eruptions. It's also vital to remember that the term supervolcano refers to the size of the eruption, not its frequency. Yellowstone is under constant, intense monitoring. Scientists track seismicity, ground deformation, thermal emissions, gas composition, water chemistry, and surface changes. Warning signs of an impending eruption would include a surge of thousands of earthquakes within a short period, noticeable ground deformation, and unusual gas emissions. While Yellowstone appears stable for now, the potential consequences of a major eruption are sobering. Ash dispersion could blanket a 500-mile radius, crippling agriculture in the Midwest and clogging vital waterways. The injection of ash and gas into the stratosphere could trigger global climate effects, potentially cooling the planet for years to come. Recent research indicates that there may be more liquid molten rock beneath Yellowstone than previously thought. However, this discovery does not necessarily indicate an imminent eruption. The sleeping giant continues to slumber, but the world watches, aware of the immense power it holds.